And thank you all for joining in. It's a pleasure to have this this webinar with Christophe Vidal, who is now showing on screen as well. And he works at Pivotal, and I would like to get started. As Kendra said, this is going to be all video. We get your input, and we will we will answer your questions as we go along, as long as we can look at the chat. And I would like to introduce, to have Christophe introduce himself and tell us what he does at Pivotal. So Christophe, welcome first.
Yeah, thank you very much, Monica. Thank you for having me. So I'm working at Pivotal. So Pivotal Commware is a company, a startup that is making beamforming antenna, so this new generation of antenna. And in part of that, we are building a system to control these antennas and optimize the antenna. And I'm in charge of the department building this system. And that's, you know, the very topic of this discussion. And
yeah, absolutely. So that's great. So what we're going to talk about today is the overall network optimization. That's a crucial element. You know, when you have a network, you're building a network, or you have a network, it's a crucial part of running it to optimize it. But to date, the level of optimization has been relatively low to date. And this is because I think in a lot of cases, well, generally speaking, the networks were so simple that there was little room to optimize. So if you have a voice-only network, there's not much to optimize because you have just voice. It's just minutes. You know, how many voice calls can you host? Now, as we move towards 4G and then 5G, the complexity of the networks increases, and what that gives you is the opportunity to optimize because you have more flexibility. There is more variability, and so there is more of a scope for optimization. But this is all early days. So what we're going to talk about today is how is that going to work within the RAN, and especially with antennas. And so that's all. You know, it's all work in the progress, right?
Right. I guess the optimization, like you said, I mean, when there was initially with this, the 2G only voice, it was a question of optimizing a service. Then we added multiple services with the data. On the network side, the optimization could be quite complex because you have to play with literally thousands of parameters. But until now, the part that is really the RF part, so purely the antenna, most of the antenna are static antennas, so you can, with the 4G came the generalization of REDs, the remote electrical down tilt, or up tilt, so you can basically change the tilt. But changing the azimuth means sending someone on site. So in terms of optimizing purely the RF, it's a very heavy work. So all the optimization was actually done purely with parameters and changing parameters, and try to compensate this lack of flexibility of the antennas, I would say, by adding parameters and moving parameters and playing with the hysteresis. So that's where the complexity is, and I think that's where this new generation of antennas and new generation of network is bringing a change in optimization, which I usually say it's a new paradigm of optimizing, because you can actually now with these beamforming antennas, you can actually change tilt, azimuth, beam width with software. So you don't have to send anyone on site. You don't have to rely on multiple paths that are more or less reliable. So basically, that means that it introduces a new active component in the optimization that may change the game.
Mm-hmm. Yeah, so actually, we have the first poll. So we're going to keep polling you guys and hear what you think, so that we use that to move on in the conversation. So here, Kendra, can we have the first poll? to see what you have, what experience you have, what's your view on RET. Is it working? So let's just start with sort of the past, and you can vote. We're seeing the votes coming in, and this I think it's the change in the antenna from passive to active antennas. It's only one of the different components of the increasing complexity. So if you look at the network end to end, there are so many areas in which you can improve. But clearly, antennas it's a major one, because that's something that if you do not optimize it, then you end up investing in something that you don't get the full benefits from.
That's especially true with the cost of the spectrum, right? I mean, right now you're spreading the energy all over the place because you're trying to blanket the coverage, because once you put the antennas in the field, you can barely move it. With the automation and the self-organizing network and the so on, you can do some of the changes, like I said, the tilts basically, but it's something that is very limited. So most of the time you do the planning, you do some RF optimizations through services, or doing slight changes, but you're quite limited. And right now, with the antennas that you have, you just need to trick the coverage with parameters, I would say. Mm-hmm. With these new antennas, you can now basically change, at least you can also look at it as a very minimal trial. You can change the tilt and the azimuth just by sending a software command. So when you do some of the trial, that's what we can demonstrate is, changing actually the coverage without, during the day having several different positions of the beams without any intervention on site. So that's what's changing. And if you think about it, if you have several of antennas like that and you start being able to have all those beams on demand, like we call them, then you need to have a system that will be able to coordinate all these antennas and these beams so that the network is optimized, right?
Okay, so let's see what the audience thinks. And Christophe, what do you think about it? Is that surprising?
From my experience, I'm looking quickly at the results.
Actually, can I just quickly summarize them
yes.
For the people that will listen to the webinar offline? So we have 18% of the people think that RET works over 80% of the time. 27% thinks that it works 50 to 80% of the time. The majority of respondents, which is 33, the largest group in the respondents is 33% thinks that it works less than 50% of the time, and 22% say, I don't know. So, Christophe, what do you think about that? Is that surprising?
According to my experience, it's not that surprising that actually, people are thinking that less than 50% are, fully operational. In my experience from the trials I did in a previous job that I had, and because I work on the operator side, many years, most of my career, you'll find out that actually you got a lot of problems with the remote electrical tilts, and since to fix them you need to send technicians on site. Actually, the proportion of RET that are not working or partially working, because sometimes they're only partially working, so not giving you the right values, for example, is quite high. And that's a real problem, because if you cannot trust fully your remote electrical tilts, then any kind of automation or optimization that you do on the top can be an issue. Mm-hmm. And I think that's where these new beamforming antennas or phaser array are bringing a brand new concept, a lot of reliability and a new. I would say you can trust more the optimization that you can do on the RF side, basically.
Absolutely. So there is right, that's one thing.
Yeah.
And clearly you want to reduce as much as you can back rolls and direct intervention. But sun was the other thing that was supposed to take care of a lot of the optimization part. Actually, we do have a poll on that as well. So maybe why don't we start on that? Because Sun, had the great promise of automating the RAD, optimizing it. And so let's actually ask, Kendra, could we just get the second poll as well? And talk a little bit about to see what you guys think about Sun. And there is a lot of work that is currently being done to the sort of the next generation of Sun. So
No, that's true. I mean,
yeah.
the sun brought, I think, the automation that was needed. A lot of things were done manually. So it's not only the rate, but it's the whole system managing the neighbors, managing the traffic. So the sun is really right now targeting the RAN, the radio access network, and it should expand eventually, normally to the core network, transport network, and the problem is if we recenter to specifically the antennas, the only way to act on the antennas would be the remote electrical tilt. So with those antennas, the phased array, antennas or the beamforming antennas, actually, you can get more than what you have right now. Is you cannot act much on the antenna. That's what we're doing. So the sun is basically limited in its action by this kind of limitations, also with the information that you get. So the data that you get from the network, there is some delays. 15 minutes is the most that you can dream of right now. So I would say the sun brought some automation, but compared to what was advertised, I would say at the beginning, I think it fell a bit short. I think that's what Paul is more or less showing.
So, so here's what we hear from the audience. 50% say that Sun is not delivering on the promises, and 3% says I don't know, and 21% says yes. Again, Christophe, what do you think? I mean, I guess it's not really surprising. There has been a lot of work attempts, but not too. I guess that the issue is that when you optimize, there is always a lot of learning that needs to be done. So it's not, you just don't optimize. I mean, it's a long process, especially because in telecoms, the amount of optimization that we had in the past was so limited that it's something that we're just learning as we go on.
Yeah. So I discovered Sun when I was on the operator side, and then I moved and I contribute to actually building the Sun, a Sun product. I think from what I've seen on the operator side, what was promised is a lot of automation and in the network, but also it's a little bit like you presented. As a client, I was presented like I would have on my desk a big red button that I can push, and then the network would be optimized. Creating the Sun, that it was never in the picture. It was much too complex, and the Sun is bringing some algorithm, but you have to interact with multiple pieces of the network, with multiple vendors, multiple interfaces. So that's where the complexity is actually. And like I said, you need to have reliable data. So that's not always the case. Sometimes the data are delayed. So when you get closer to the radio, you need to act faster. The problem is if you have an information that is produced every 15 minutes, that you get the information 20 minutes after it happened, the time to react, you need 15 more minutes to put the new values and so on. You're losing a lot of time. So basically, that's a problem that we had with the Sun, beyond the fact that what we were discussing before, that actually antenna by itself, you're very limited in the action. So I know that now you would have antennas that will be more flexible, which normally the system we're working on actually to contribute and interact with these antennas and provide the data and actually optimize these beams would be complementary to the sun, will help the sun to get access to this part of the RF that doesn't have access right now. So I agree with the poll. Compared to what was advertised and what was produced, the sun was very limited. I think it brought a piece of automation that was very valuable for the operators. I have an example, for example, in my personal case, my teams in the fields were producing a lot of effort to just manage the neighbors. So having the ANR, the automatic neighbor relationship, helped a lot. It freed more than half of the time of my team that could concentrate on optimization, a little bit more sophisticated and a little bit more with more added value, I would say.
Yeah, absolutely. And, there is complexity, and also there is the element, the real-time element that we didn't have before. So initially, in the past, what you'd optimize was something that you do offline. You look at historical data, you figure out what's the best move, way to move forward, and you're done. And you might, refine it, but it's a very self-contained task. With sun, when you act in real time, because the network's changing real time, and because the user pattern, traffic patterns change in real time. That's a different type of challenge.
Right.
And when you do it on time, you need to be automated, because you cannot have too many people there actually doing the optimization or refining how the network works. So so there is a question of the real time, and how do you define real time? How quick, especially with regards to antenna, how quick do you need to be in order to get the maximum value? Because if you do it too much in real time at the millisecond level, clearly the overhead cost is too high. So you want to make sure that you hit a sweet spot, so that you can optimize without paying too high of a price.
No, that's great. That's great. I mean, the real-time question still depends on who you're asking. You even have this expression near real-time, which is faster than what you have, but not as fast as pure real-time. So there's a lot of debate about what real-time is. If I go back to the antenna case, you're right. I mean, the thing that you can have the beam on demand, you can move, and in our case, we can actually shape the beam the way we want, but you cannot have technicians or an optimization engineers with a joystick behind the antennas and just moving the antennas regularly. So that's where, as a software-defined antennas, the software is coming in. Now, you can see two parts of the software we're working on. One part will be more centralized, so it's an actions where, for example, the very first use could be changing the beams depending on the rush hour or not the rush hour. So you don't need to act like, at the second. It could be a couple of hours and so on. So you can manage that from a cloud system, and even, having much lower granularity, like at the minute or 5 minutes. Now, like you were saying, you can go down to the millisecond or sub-millisecond, but in that case, that means what we're planning is actually to have an embedded software that is able to do that right at the antenna. It had to be coordinated, but like you said, the latency of the network at that time is, looks really huge if you want to act like sub-millisecond time frame. So there is a part of the system that you will need to get embedded in the antenna, so that it could act, within this real-time time frame.
Yeah, so that's interesting. So we have a different sort of like, again, like the sort of the edge component, or where do you have the processing? So there's going to be different elements in different locations. So we have to think about it more of a what is that need to be done at different time scales and at different locations, which again adds another element, another dimension of complexity in this whole system, which is the way I see it is complexity, but it's also an opportunity, because with the complexity comes the opportunity to use the complexity to your advantage.
That's
if
correct.
Correctly.
Yes, yes. The problem with the complexity is you need to manage this complexity so that you can focus on really where, as a human, you can add value. So that's where the software is important. So that everything that is automation need to be right there, which wasn't the case initially with the sun. So the sun had to cope with a whole system that wasn't really planned for it. The thing with these new antennas, we're trying to plan a system that is going with these antennas, from day one, so that we have an impact. We can create the product that would fit the software that we're creating at the same time. And I think you have a good point. I mean, this bringing a new way of thinking. We can't think statically now because most of the planning of the RF planning was really static. Now we need to think dynamic coverage, especially with the 5G coming. So you have beam sweepings, you have the beams that are changing. So you slice in frequency, in time, in space. So the complexity is there. You need to have software that would support that. And then you can actually, after that, tune the software according to the marketing that you want to do as an operator. If you want to put more emphasis on the reliability of the voice or the quality of the voice, or some data services and so on. So that will give you a lot of flexibility that we need to manage.
Now we have a lot of questions, but I wanted to talk a little bit about the learning part, and then I guess we can go to the question, if that's okay, Christophe. Is that? Yeah. So okay, there is clearly a lot of learning that here needs to be done. So as you plan, you want to also look, as you in order to optimize, you need to understand what's going on and react to both the immediate condition. Is it rush hour or not? Something happened and you need to change things. It's a sort of unpredictable event. But also you want to look and learn from the past. And again, since you have so many parameters, it's not just the simple trivial learning that you say, oh, let's see what happened yesterday. Okay, that's what we're going to do today. It's much more complex. There's a huge amount of data that you need to use for learning. So it's not. So one challenge is that in order to optimize, you have to optimize over your 1,000 parameters, but you also have to learn over 1,000 parameters. How is that? How do you see that done?
Well, and definitely, it's already coming to the sun, but the algorithm now will, like you said, use machine. And I think I used to pinpoint the fact that the data is very sensitive in the fact that you need to be very careful of the set of data. We'll get a lot of data, and we can have measurements directly from the antennas, also through the software. Now, what we need to make sure, and that is also a problem with any automation system, is that your set of data is actually not biased and reliable. So there's a lot of work to actually sanitize the data to make sure that the data you get is current, is representative to what you want to do, so that the learning that you built on top of the data is actually producing the answer that you want. So I know it's not the part that is really that we see as intelligent, because most of the time when you look at the machine learning, it's all about algorithm and so on. And there's a lot of tremendous, very interesting work done on the machine learning and on that side. And we have now tons of very powerful algorithms. The problem is you need to make sure that what you feed to this algorithm is actually representative of what you want to optimize and to achieve. And that's a big problem. That's a big problem because in the networks, you got latency. Like I said, you've got a lot of delays. Sometimes the data is going through gateways. Sometimes you lose the data. In terms of priorities, of course, in a telecommunication network, the service, providing the service is number one. Then changing the configuration or monitoring, if your site is, limited in capacity because, you have a lot of traffic, of course, the first thing that will be dropped is the monitoring. So you'll be missing the data at a moment where maybe you need it the most. So you need to take that into account and make sure that your data is not biased so that the results and the learning that will come out is not biased by the set of data that you're having.
Absolutely. So when you think about the learning, and you said it's important to have the right data, reliable data, and sometimes you might get reliable data from the whole network, from a single site, from a region. So there are different levels at which you can learn. And so there is the time component. You can sort of learn over what happened over the last day, last month, last year. But let's say you have a new antenna system in place. How is that learning going to progress in terms of, can you generalize over sites? And then what you learn, you apply to different ones? Or do you need to do, or is the learning specific to a site? Or it's a combination of both?
No, I see. That's a very good point. I would say it's a combination of both in the fact that it will depend on the use case that you're targeting. So let me give you a few examples. If you have a hotspot that is really localized, then you'll try to look at the site level. In terms of time, that could be looking at patterns across the week to see when this particular area within a couple of antennas is actually getting really hot and there's a lot of traffic over there. That could be commercial center, that could be a business building and so on. However, if you're looking at the flow of traffic, for example, across the markets, city, then you will need to aggregate data across many antennas, 100 of antennas. So it's a very good point, but it's kind of difficult to answer the questions without attaching that to your use case. And I think it'll depend a lot of the use case. Same thing for the time, the granularity. If you're looking like we're talking about, the difference between rush hour and not rush hour, or business time versus non-business time, then you don't need to be at the millisecond level. Now, if you want to have eventually a system that is what used to be presented in the sun, that was a bit sci-fi from me, my side, like developing the sun. It was basically a per customer sun, meaning at one point I saw some of the feature on the sun where technically the system was supposed to be optimized for your own need. So you would have your own tweak of parameters for you. I have my own tweak of parameters for me, for what I'm doing. Now, if you want to do that with the antennas, you can eventually think about having a beam that is, you can have a beam width that is small enough that you can target groups of UEs. So in that case, you might want to react much faster. So in terms of data and data set and learning, you may have different learning with the same data set because you will split the data set differently.
Yeah. Well, and I guess it has to be a closed loop, so you need to continue to learn as you go. So it's not that you learn, you're done learning. It's not like you go to school, you got college degree, you're done. It's just like I guess it's not the same thing. It's like you have to keep learning as you go along. So, and keep refining.
No, that's a good point. In a way, I would say it's a little bit like you go to school. I mean, I got my diploma like years ago, and I need to keep on training, right? And so true for some of industries. I mean, you learn it and then you're done. But most of our society now, you need to learn continuously. You can't just say. I mean, you have laws or formulas of mathematics that won't change, but you keep on having new algorithm and so on. So I guess in a way, it's a little bit the same thing. The network keeps on changing. You have new phones, you have new services, things that you can't predict. So you need to adapt very quickly. And that's where I think it's a key to have these antennas that are flexible enough so that you can adapt to the service, because someone in the marketing will get with a great idea in the morning that is a new services, had that in the past, and then you have to optimize it. And then you explain to the marketing guy that you need 12 months to optimize your network. And then that doesn't fit really their timeline, right? So having something that is much more flexible is actually bringing a lot of possibilities. Make the network more adaptable to whatever services you can bring.
Absolutely. So now another question is that, we talked about the RAN, but clearly the other important half of the system is the device. And so how is the, again, you want to look at, obviously from the network point of view is what you can adjust and optimize. But can you leverage what's going on in the device and the devices themselves as part of the optimization of the antenna performance?
So actually that's a good point, because once again, the UE is part of the network, and the sun was supposed to leverage some of this, but at the antenna, basically the antenna and the UE are communicating all the time. So having the data directly, the feedback from the UE is also essential in the fact that you get both ways, so downlink and uplink, but mainly you got a lot of information of the UEs, what the UEs is saying from the network. So we were looking at crowdsourcing basically this information so that we can have the feedback of the UEs and accordingly reflect that on the antenna positioning and tuning. What we have right now with the networks is most of the operators have some kind of application on the UEs that are sending back information that is completely anonymous, but just giving you labels of energy that the mobile is receiving and interferences and type of the quality of the transmission, the throughput, and all that stuff. So there is already a lot of data that is collected that can be used. So we're back to describing, gotta change in the
Yeah, okay.
Basically the data is there. Now you can find some patterns in this data. We're planning to see if we can stream some of this data also for some of the mobile to get a better granularity, which is done somewhere in the network because this data is collected. So I think it's important to have different sources also of data. It would be the antenna, could be other pieces in the network, because that helps to get reliable data, like we were talking about before, and having some kind of correlations and making sure that what you see on one side is actually what is reflected on the other side. So the UE is definitely one part of it, and it's something that we would need to work with. That could be through the operator themselves, or that could be by having some way of getting this data directly from the UE.
Yeah, and I think that this is really important, because when you optimize, the question is that what are you optimizing for? And so the question is that, do you optimize for like throughput, latency, so a network-based KPI or parameter? So what is it you're trying to do exactly? And if you look at it from an operator point of view, a lot of the optimization is network-based. But really, you don't care about that directly. That's a proxy of the subscriber experience, which is what you see from the UE. So you might, really the priority is to make sure that you have the best subscriber experience you can possibly have with your network. And so it really makes sense I think to bring in what happens to the UE, which is not really the traditional way of optimizing, because you need to keep in mind when you optimize what is your ultimate goal, which is user experience. So it's really important to make sure that you can take as much as the user experience and put it together. But then obviously that adds another dimension of complexity on top of the 1,000 parameters that you have on the on the RAN side. So that but I think that's really important. And yeah.
And actually, the standards are looking at that. I mean, they've been working for a while now, trying to get more information from the UEs, because you can see also all the UEs as little probes, of the network all over the place. And I don't think we're leveraging enough, these probes. And like I said, there's tons of just purely physical information about the level received and so on that we can actually use. So it's much better now. But I think we can even do more, and especially if the UE can basically be in the field. I mean, you can. I don't want to do the oversell the new technologies with the antennas, but basically you can almost imagine that you have a UE sending a warning saying, "Hey, I'm losing the signal here." The antenna is able to refocus a beam on it and then say, "Hey, okay, here you go. Here's your cell. Here's your energy. Here's your." You have a better beam now because you can finish using your services or your data transmission or whatever.
Absolutely. Now there is one question that I wanted to pick up, and it's it talks about the fact that in MIMO antennas and beamforming, there is a trend to have integrated radios. And so the question is about the impact of integrated antenna radio solution when you use a third-party antennas. And I think that sort of brings the issue of interoperability and how this optimization work across different vendors. Because obviously an operator will have multiple vendors in their network. How do we deal with that?
So that's a good point. So basically, the way we are interacting right now with our customers and looking at trial. So we're producing an antenna that can be plugged into any kind of systems. So the way it's going is we're going to integrate more and more at the antenna for sure. So since we have a module on the antenna that has an embedded software, we can do, so it all depends how much you can do, of course. Then you design the antennas with the components that you may want. But we have also the capability of generating our own data and sending that back to our cloud, so that we can optimize in parallel of the system. So we're not fully dependent of the different counters of the different systems. So for example, if our antenna is plugged into a vendor A and a vendor B, they might provide the same kind of information, but what you find out, and that was one of the prime also that I was telling about the sun, is you may have the same kind of counters, but sometimes they're slightly different from one vendor to another, and you have to cope with it. So if you build a KPI, you have a nice formula, but then you need to adapt, to tweak a bit your antenna from one vendor to another, because you have to take into account that their counter is not exactly the same, or they're not counting exactly the same thing. So you have to compensate here and there. So that could be a problem, beside the fact that then you need to retrieve the counters, somewhere in the network, so you have some delay. So we came up with a system where we're able to actually get a minimal set of data that we can use to do the optimization directly. So in terms of this integration, we're able to integrate and partner with the network vendors, so the equipment vendors, so that we're fully integrated in their system. And we have the options also to integrate more on the antenna side. It's just a matter of, basically managing the costs and the capabilities of our antennas.
Yeah, and actually that brings the issue of the AI machine learning as a sort of as a black box. So you hear sometimes people feel a little bit, I don't know if it's a worry, frustration, or sort of like, or just lack of comfort with the fact that when you have a machine learning type of environment, you get all sorts of data, you have huge amounts of data, and then you have a recommendation at the end to optimize one way or another. But it's not transparent how that is. I mean, it's perceived as a black box because what comes out is not directly, it doesn't relate directly to one cause. So you're not saying you should do this, you should do A because of B. It's you should do A because of many things that happen and I think that that's actually that's the whole point, and that's the reason why we need machine learning in the first place, is because we don't have this sort of like if A then B type of situation anymore because of the complexity. That's all good, but in terms of like having operators using it, is it a barrier? Is it something that is slowing down the adoption because people are worried about this sort of black box component?
No, but it's it's a very good point. It's actually a big area of research right now, right? I mean, to understand, for example, for the deep learning networks, like these neural networks with many layers, to try to understand how they come up with a solution. We're trying to understand, basically what's happening in this black box. Now, that being said, I'm back to my data. I need to know exactly what I feed the system. And after that, if I can basically control and make sure that the data I have, that is the base of the learning, is actually reliable and representative of my problem, then I can trust the black box to come up with a solution, even if I don't understand all the nitty-gritty details of the black box, right? And we have a lot of systems now that we may not understand completely in details, but we trust. Take your car, for example. The car has a lot of software now inside. I understand generally how an engine is working, but have absolutely no idea of what optimization is doing. I'm just happy that I could come to work in the morning. So I think you don't need to understand the whole details of what's happening, but you need to understand what you're doing globally. So what you feed the system to how the results are. The problem I have with the machine learning sometimes is it's used sometimes over a database, and we see what's coming out, and you have no idea. You're like, okay, find a pattern. The problem is, by doing so, back to my concern about the data, is if you don't know exactly if your data is biased or not, then you don't know if your decision will be good or not. So, and we have a bunch of statistical tools, especially if I limit that into our domain to see what we want to optimize. So we can see if our data, for example, is mainly measured when we have specific conditions in the network. So if we have mostly our data when the network is overcrowded, then we may have a bias because we are limited in capacity. So we need to take that into account. So in a nutshell, my point is control your data, and then if you know what you're feeding the system, normally you shouldn't have too much problem if you don't understand all the details in all the parts.
And I think that sort of brings the humanity back onto the machine learning and AI, because oftentimes people think, and this sort of goes along with the black box concept, that it's a black box, it has a life of its own, and so you feel kind of overwhelmed, and the human component is sort of like, we're no longer necessary kind of approach. And I think that that's what you're bringing up is exactly the fact that this is a complementary to our role. So there is still a big role that humans play in this, in directing, and for instance, making sure that there is no bias in the data. Because obviously, if you have a machine learning type of environment, well, it might detect some of the biases, but a lot of the biases and a lot of the relevance of the data, the fact that the data is representative of what goes on in the network, that is correct. It's something that humans have to do it on the outside. It's sort of outside the black box. And so by knowing what goes into the black box, you have some understanding of, or you know how reliable the outcome is. And as and then you can sort of circle back, and you gain comfort as you go along. So if you see that the prediction actually resulted in better performance, then you start building, start having confidence. You start having confidence in your data, in the black box, and in the optimization. Now I wanted to do the last poll and also go back to the questions. Why don't we do the last poll, and then as we have people to vote on it, we can look at the questions as well, which we have a lot. So in fact, when you see us glancing at the side and not looking at you on the screen, is because we're sort of trying to track to read the questions as well. That's the real time, our limitations in the real time here. And a lot of the questions that Christophe has are for you, so you can try to address. And so the last poll is about 5G. Is the antenna technology ready for 5G? And I guess we can. I guess we're good to go. We got enough. Okay, that's okay. You see the results here. So there is 66% of the respondents think that antenna is ready for 5G. 24% say no, and 12% say no. So what do you think?
No, I think I would agree with that. It's kind of reassuring that people have some kind of, that most of our participants have some kind of confidence in the technology. I think if you look at the 5G and the standards, it's really all built on on beams, so beam sweeping, beam forming. I think the standard needs to evolve a little bit more from this static thinking, and that's what they're doing, trying to have statistic per beam, for example. So I saw also that in the questions there were the comparison between the antennas with massive MIMO and these. I would say, from my point of view, Pivotal is doing one type of antenna of beamforming. You have different technologies. So my point is not discussing the different advantage of one technology to another. From where I'm sitting, what I'm looking at is there's definitely a need for a system to coordinate these new antennas and these new beams, and that's where we are. So it could be antennas like phase array, it could be the antennas like ours that are doing holographic beamforming. It doesn't really matter. It has to be integrated, and it's kind of a lower component that will enable the sun to be also more effective. So it's all complementary to what we have right now. So I think the technology is here. It will all depend how it will you will deploy these technologies, and I think the millimeter waves are also bringing their own set of problems and issues that weren't common. I guess I'm in line with the poll.
Mm-hmm. Yeah, absolutely. So is there okay, so we have a lot of questions. I don't know where we can go through all of them. Okay, do you want to, any questions? I think that mostly are for you.
There's questions about the run engineers, and lots of work has been taken by Sun and the automation technique. So that's interesting because I've been working with Sun, and within the companies also, at the vendor side, you have services and you have some kind of competition. And I came up lately with the same kind of stuff saying, oh, well, with these new antennas, you have a whole set of services that are done within the operators or from the vendors that are actually optimizing the RF, so managing the overlaps. So now if you have a system that is, if you have the antennas that are flexible in it, that you can change from a software, and then you have a software that is managing that, then these kind of services are not needed anymore. But so the way, my experience, the way with the Sun is there was a lot of, I would say, mechanical tasks, like adding a neighbor, removing a neighbor, that was done manually. And it was a bit of a waste of your human resources, right? I mean, you want your optimization engineers to focus on problems that are maybe niche problems, but important problems, and take time to think and be creative on some of the solutions. So these softwares and this flexibility with the antennas will address the problems that are really mechanical, that doesn't need a lot of added value. So I think it will help for all the optimization engineers to focus on more added value. A lot of things that we cannot do. I'll give an example that is based on Sun as well. You have some parameters that are cell to cell, so from the source cell to the neighbor. And you can have literally tens of neighbors. You never have a team that is big enough, to optimize those parameters. So the result is before the Sun, you would query the network and all those parameters will be at zero, because there's no way that you can find people to tune that. The only case where it wasn't in zero, it was very specific case where you need to tune the these parameters for going over a bridge or very specific areas that were in the network. Bringing the Sun in, you were able to actually fine-tune those values everywhere. So that was a capability of the network that wasn't used because nobody could handle it, but with the software we could bring that. And for the antennas, it's the same. And if you look at the antennas, sometimes you would be really surprised, and that's like the rate for the pole. We're saying, oh, well, we have a lot of rate and it's working, it's fine. The problem is you come up with the fact that you find out that a lot of rates are actually not producing what you want. So just detecting that by software and having an antenna that can actually use that will help the engineers to focus on some of the problems that are really needed to be addressed by someone that is optimizing really the network rather than just doing mechanical work.
Yeah, well, there is a thread through the questions that is basically asking how much improvement should we expect. And what I've seen in the past from others trying to do this is like a 20% increase in capacity, and that's good. That's very good results, right? But I think that there is more than that, more than just an increase in capacities, and that goes back to what somebody else mentioned, slicing, and the question is that is the increase in capacity capturing all the improvement, or is there something else that is a little bit more subtle? Because the more we can optimize for a specific goal, you're not just trying to increase capacity, but you might be trying to support different use cases or different applications or different traffic flows. So you're not necessarily trying to maximize how many bits you send through RAN, but what kind of bits are more valuable to you should go first, and then you can have the antennas, through being MIMO, to basically target those specific traffic. No. So it's not just one percentage number, which is very, it's step one. But can we do more than just increasing capacity or say reducing latency?
Yes. So it's always difficult to quantify to have a generic number. I was caught a little bit by, I was even trapped a bit with the sun, because we were trying to come up with some of the numbers, and it varies from one network to another. And also, the networks may be improved, but not in the same way. And I think with the new antennas, what we will find is we always have a compromise between capacity, coverage, and quality. Because when you have static RF, you need to move it the way that you maximize capacity or you maximize quality. But if you put everything on the quality, then you're not optimal on capacity and so on. With those new antennas, actually, you have much less compromise to do, because you can slice in space as well. And in that case, you can try to have the best in capacity without sacrificing coverage and quality. So it's a new approach, and it just by that, it will bring a lot of improvement in the fact that where you maximize one of the three components, you can actually gain of the two others. So until now, we really had to build this compromise. And one of the questions on the operator side was, okay, do we want to maximize the capacity here, or do we want to maximize the quality? So you will find actually different business models with the operators if they wanted to build, more cheaper services or more quality services. So yeah, it's a bit. I think it's almost a case by case questions. So.
Yeah, but I think that sort of as you say, it's difficult. So it's clear you want to have this is the improvement, but I think that there is more, and that as we go along, we will understand it better, and so there is more of a concept of what you optimize for. You say capacity, quality, and so the whole and that sort of fits in with the whole idea of having network slicing, of managing the network end to end. So I think it's very interesting, because you're going to be able to do the antenna optimization not as its own island, but within the context of the end to end.
Right, and I think with that, I would almost say that the optimization will be now per service, especially this concept of slicing, but. Rather than focusing on this compromise between capacity quality, you'll be able to optimize, per service, and that's really what you want on the operator side, being able to design your service and say, okay, my network will adapt so that I can provide, the best service as I define it.
Mm-hmm. Now we are on top of the hour, so I would say that what we could do is to try to answer your questions offline. There is some that we didn't manage to go through, unless we have some that you really want to address at this point.
No, I mean we can. We're already. We can address some of the questions, but there's a question. It is asking about the type of Sun software programs, and there's many Sun, and actually it applies to all the use case. So there's no specific Sun programs that we're using. We're actually building our own system and integrating with the different Sun. So otherwise, I mean, I can answer the other questions offline if it's possible.
Okay. Okay. Well, Kendra, back to you then.
Okay, great. Well, thank you everyone for joining us today and for asking so many great questions. This Sparring Partners webinar with Pivotal Commware will be available on demand on sensafiliconsulting.com, and we will send an email out to all the registrants with instructions on how to access the recording. Well, thank you very much, and we hope to see you next time.
Well, thank you.
Thank you.